Hello everyone. Today we are going to discuss one of the most fascinating and fundamental ideas of computer architecture or computer organization. That is the fetch, decode and execute cycle. Every action your computer performs, whether you are watching a YouTube video, typing a message or running an app, ultimately happens because of this tiny but powerful cycle repeating billions of times per second inside our CPU. So what is this fetch, decode, execute cycle? The CPU or central processing unit doesn't do everything randomly. It follows very strict repeated routine to carry out every instruction of a program. And that routine is called as instruction cycle, or more commonly known as fetch, decode, execute cycle. Let me simplify this for you. Think of your CPU as a worker in a kitchen. The worker has a recipe, that is a program, and it follows it step by step. Each step in that recipe is an instruction. The worker fetches the next instruction from the recipe, decodes it, understands what to do, executes it, actually performs the task like chopping, mixing, etc. Once done, the worker immediately goes to the next step and repeats this routine, fetch, decode, execute, again and again and again, extremely fast. Now, when the CPU begins working, the first stage is fetching the instruction. Let's relate this to a real life. Imagine you're following a recipe in a cookbook. Before you can do anything, you need to look at the next step. That's exactly what fetching means in computing. The program counter, now let us understand what happens inside the CPU. The program counter acts like a guide, showing where the next instruction is located in memory, just like keeping your finger on the next step of the recipe. The CPU then sends a request to main memory to get that instruction. Once the instruction arrives, it's stored temporarily in the instruction register, that is IR, like keeping the current recipe step in your mind. The program counter then moves forward to the point to the next instruction so that nothing is missed. To make this happen, three important roads inside the CPU work together. We call them as buses. Let's compare them to the real world delivery systems. First is address bus. This is like the GPS or address tag that tells the CPU where to find the instruction in memory. Second is data bus. This is the delivery truck that carries the actual instruction or data from memory to the CPU. And third is control bus, which acts like a traffic police, directing when data can move, when it must stop, and when to read or write. So inside CPU, these three buses coordinate like a team, ensuring the instruction reaches the processor at the right time and in the right way. One can think of it like an online delivery. Address tells where to pick up the package, delivery van brings it, and traffic signals control when it moves. Now that the instruction is inside the CPU, it needs to be understood, and this is the decoding stage. Imagine again, you are following a recipe. You are reading the step. Now you need to understand it. For example, the step says chop the onions finely. You know what action is needed, like chopping, and what material it applies to onions. Similarly, CPU uses its control unit to decode the instruction. It reads the instruction from the current instruction register value, CIR or IR. The instruction is split into two parts, opcode and operands. The operation to perform is opcode. For example, add, move, compare, etc. Operands, the data or memory locations involved in the process. Once decoded, the control unit figures out which components need to work. Maybe the ALU, arithmetic logic unit, for math, or some registers or memory units. Now stage 3, the final stage. Execute, that is carrying out the instruction. After decoding comes the execute stage. This is where the real action happens. Let us go back to our own example of kitchen, which we talked about earlier. Now you have read and understood the recipe step. Now you actually have to do it. Chop, mix, and heat. And that's the execution. In the CPU, the same happens. If it is calculation, the ALU performs addition, subtraction, and comparison. If it is memory operation, data may be loaded from or stored into the memory. The result is stored or placed into a register like accumulator for quick access. And if the instruction involves control flow, like jumping to other part of the program, then program counter is automatically updated. So execution in the stage or is the stage where the CPU truly works and completes the instruction. So now you can imagine the CPU as a tireless worker performing this loop continuously. Fetch the next instruction, decode it to understand what to do, and execute it to perform the action. This process happens billion of times per second, making our phone, computer, or even our smartwatch functioning smoothly. To connect with daily life, every time you click an icon, press a key, or watch a video, behind the scenes, millions of these fetch, decode, execute cycles are happening almost instantly. So to wrap up, the fetch, decode, execute cycle is like the heartbeat of the CPU. Without this cycle, no instruction could ever be processed, no software could ever run, and your computer would simply be an empty box of circuits. So remember, the CPU's rhythm of fetching, decoding, and executing is what makes the digital life possible, one tiny instruction at a time.